ஒரு பையன் சீன் போட்டுட்டு இருந்தான்.
Yeah, good evening.
Good evening, everyone, and a very warm welcome to all our participants joining us today for Season 7, Talk 29 of GCT Talks. We at gSARC are thrilled to have you here this evening for yet another insightful session where we explore opportunities, advancements, and career paths in ever-evolving world of engineering and technology. Today's area of discussion is unlocking careers in the energy sector. And we are fortunate to have an industry veteran with us to share his valuable insights. Let me introduce our esteemed speaker for the evening, Mr. Asaithambi K S, sir. Mr. Asaithambi K S, sir, is an alumnus of the 1987 Civil Engineering batch from our very own GCT and currently serves as the General Manager of Offshore Structures at Technip Energies. With decades of experience in the field, he has contributed significantly to the energy sector, working on major offshore projects and demonstrating leadership that has set benchmarks in the industry. We are truly honored to have him with us to share his experience and expertise. Over to you, sir.
Yeah. Thank you, Negal, for that warm introduction. I am honored to be speaking with you all today, and I would like to share my thanks to the organizing committee members for inviting me to share my insight on energy sector to young engineers of today. Yes, I will share my screen. Is it visible, my screen now? Hello? Hope my screen is visible to you all.
Yes, sir.
Yeah, good. Yeah, coming to the today's topic, just today I want to share my knowledge about energy sector. I'm going to cover this today's presentation of the simple 5 topics of overview of energy sector. Then what are the opportunities today? What is the trend in renewable energy, particularly? What are the skill sets required to get inside this energy sector? Just these 4 or 5 topics I'm going to cover. And at the end of the session, we'll have the question and answer session to discuss in detail. Coming to the energy sector, as everyone knows, it is one of the important and critical component of the modern society, where energy sectors providing the power to the home, industries, and transportation. It started with the fossil fuel, and today we are moving towards renewable energy. And today, this sector is the forefront of technological innovation and sustainable efforts. If you see the graph, the right-hand side, the fossil fuel still is dominating the power generation or the energy sector. The fossil fuel, the old traditional, is still it's dominating with more power produced from the coal followed by petroleum products and renewables and nuclear. Around 70% of our energies we are getting from the fossil fuel. And now we are moving towards renewable energy in the coming years. Little more on details about the definition. What is the traditional energy? As everyone knows, this includes coal, oil, and natural gas. These are the traditional energy, which are the backbone of the earlier supply, global energy supply. As you told, you see in the graph, this 75% today in the global, all the energies are getting derived from this traditional energy. Now we are moving towards the renewable energy. What it comprises means solar, wind, hydro, geothermal, and biomass, which are gaining importance by two reasons. One is the environmental concerns. We want to minimize our carbon footprint. Also, there is technological advancement in the renewable energy sector. Compared to earlier, there are new technologies are developing which reduce the cost. Why people are not going to renewable energy is the cost factor. Now, due to the most advancement in technological, we are moving towards renewable energy. This graph shows, the right-hand side graph shows where India electricity is produced, and mainly this is due to 25% compared to 2010. Then 84% of our energy suppliers are from the fossil fuel, and only 16% were renewable energy. And today, 2020 or 24, around 25%, we are moving towards renewable energy, and 75% are in fossil fuel. Our aim, our Indian aim is to move towards renewable energy and achieve 50% in 2030. That is our goal. And by 2030, we are going to achieve 50% renewable energy. By converting from 25% to 50%, we are moving towards, there is a big job opportunity. There are improvement in the technological and innovation sector. There is a bright future for the people entering into the energy sector. Coming to the demand, what's the demand for increasing the power is because of the population and also economic development. We need power for everything. We need energy. And today's supply from fossil fuel, we are going towards the energy sector of renewable energy. So there is a demand for that. And another two reasons is sustainable energy. We are going to minimize our carbon footprint. Mainly the two important factors in terms of the renewable energy we are focusing is solar and wind power, which is having the rapid growth in the advancement of the technology. As you told, the wind energy, so far we are all aware that wind energy, wind turbines are placed onshore. We are getting the wind energy, we are producing electricity through a windmill in the onshore, which having the capacity of 2 to 3 or maximum 7, 8 megawatts per turbine. Now the technology is developed, we are going to put the windmill in water, that is sea, that is offshore. Today we are having the technology to construct the windmill in the sea. There is a water depth of shallow water depth. So 30 meters or 40 meters, very shallow water depth, but the wind turbine need the foundations. So it should produce the power. And the recent technology in terms of the windmill, we are going to have the windmill inside the sea of deep water. So where the onshore, the wind efficiency is very less, and go the shallow water inside, efficiency is going to increase. Still, if you go inside the sea, the deep water, the efficiency of the wind is more, so that output, power generation will be more. And the new technology is developed. We are going to have the floating foundation wind, floating offshore wind. So that is a new technology. The turbine, which is put in the water, the foundation is not fixed to the ground. It is going to float, but the turbine is going to generate the power. That is the new technology we are moving forward. Like that, solar, so far we've seen solar, rooftop solar, and solar are resting on the large area. Now people are going for innovation. They're going to have the floating solar windmill, solar mill. So that is going the new technology. They're going to put it in the water. They're going to get a solar power. Those are the new technologies I've told. Other than this solar and wind, the new fuels, that is called hydrogen, they're going to generate the hydrogen, the new fuel, that is called green hydrogen. So green hydrogen, nothing but produce the green hydrogen from the windmill, which have the low carbon. There is no carbon footprint. So the hydrogen produced from the windmill are called as green hydrogen. So that having a tremendous innovation is going to have in future hydrogen car, hydrogen bus. So the fuel will be hydrogen. So carbon footprint will going to come down. These are the areas, the growth of renewable energy. Now coming to this picture, we can see where we are standing today. So if you see 2024, the major electricity generation is due to the coal. So around 30% we discussed, 30 to 40% from the coal. And next is gas. Another gas is mainly used for producing the coal. Then oil, the power generation from oil is very limited. You can see the color of red one, next one, that is very limited one. Then going to the nuclear also producing power producing nuclear is comparatively better. Then comes the other renewable energies, biomass, other things. Then solar is picking up now. You can see the 2020, we can see that. If we drop the line from 2024, the solar is going to pick up solar energy. Well, we are going to achieve the 50% of renewable energy. So by 2050, by 2030 or 40, the solar, mainly the yellow, this band is going to increase, and job opportunities in the solar is going to increase. Also, the onshore wind, I told onshore windmill. So today we are generating the power from the wind, and is going to 2 or 3 times going to increase that one. Then the top one is offshore wind. So in offshore wind, I told we are having the fixed offshore wind turbines. Now we are moving towards the new technology that is called floating wind turbines. So in future, they're going to increase the power output of the wind turbines. So if you see today, around 75% of energy from the fossil fuel and 25% from the renewable. And after 30 years or 20 years, where we are standing is going to reverse 70% of renewable energy and 25% of the fossil fuel. Still, it will continue for some more years, around 20 years or 30 years, that fossil fuel supply. But slowly it will die down, and we are going to have the renewable energies. And what is job creations? Due to this change, there is a big sector, the renewable energy sector is going to have the big change. The capacity is going to increase. There is the chance for more job creations, which different roles are going to give the jobs. There's mainly engineering, the EPC, the engineering is involved EPC, and this all the economical impact, which also manufacturing plant, where we have the solar and windmill. The manufacturing sector is going to improve, and installation people and installation team members working in this sector, they're going to big job opportunities. Also maintenance. So these are the 4 areas on engineering and manufacturing and installation maintenance, where the more resources are required to generate the energy. So the main way you are doing means economical attractions and reducing the energy cost. In this picture, you can see a more clear picture. So this picture shows if you create 100 megawatts of power, so what are the resources required in terms of different segment. The first one, you can see the project planning, the starting of the projects, maybe less than 1% of the people required starting of the project setup. And manufacturing, once the renewable energies, the manufacturing component you have to manufacture, where the resources required is around 10%, less than 10%. The major resource required for our renewable energy sector is EPC. So EPC is nothing but engineering, procurement, and construction. We are going to discuss in detail about EPC in coming slides. So where EPC is more engineers are involved, more skilled people, engineers, highly experienced people in the sector, they neck around 50%, less than 50%, say 46%. Then another major people required for this sector is operational maintenance, where the global is expecting around 42% of operation and maintenance people. So this comprised with skilled and semi-skilled. So not all the people may be skilled people. This operation maintenance, there are mix of skilled and unskilled people. And decommissioning, once the project is completed, once the life period of this structure is over, then we have to decommission. Decommissioning mainly for offshore, we are going to install your turbine power plant inside the water, and its life is over, and you have to remove the structure. That is called decommissioning, and you have to remove the structure. Even in onshore also it's applicable. So there are also some resources required. So 3%, around less than 5% people will be required for the decommissioning. If you see this pictorial view, around 50% of resources of skilled people, of qualified engineers are required to execute the EPC job. This means all the energy sectors that need people is roughly, they calculated for 100 megawatts. But the power required for us to meet our 2030 goal is in gigawatts, not in megawatts. So you see what kind of quantum of people, or what are the resources required for people to generate power. In this picture, you can see the growth of the growth of renewable energy, electricity capacity year on year. So year on year, the capacity is increasing. Is indirectly nothing but they are going to produce more power. For that, going to more structures, more resources are going to involve. So within 2-3 years, you can see the jump in the gigawatts from 2020. It's 3,000, now it is 4,000. 1,000 gigawatts of power are producing. For that much project is developed. So much resources are involved in generating the project. So another little more clear, but this global resources for overall. So the same people working in the different sectors, solar. See the number of people they calculated, they arrived at the total numbers. So around 16.2 million jobs are created in 2023, mainly for the renewable energy sector. So mainly the solar, there's around 7 million people worked in solar. You can see from 2012 to 2023, the number of people working is just 7 times increased, where more innovations, more works are going on in the solar. Then bioenergy. Bioenergy is another component where the sustainable fuels, chemicals they're going to develop. And for that, around 3 million people are working on that. Then hydropower, then wind. Wind energy is going to coming days, based on the technology. When the cost is come down, people will go for wind, both onshore and offshore. This picture gives, there is tremendous progress. You can see the linear variation. People are required every year, there is, people are increasing. So the coming year, the projected 2025, the projecting 20 million people will be required to meet the energy demand. So everywhere, every year on year, the people required to work in this energy sectors are required more people. Then another interesting factors, many of you interested to look on these pictures. So this picture shows the salary, the annual salary of people working in, mainly this captured for oil and gas sector. This long term means permanent people working in the permanent role, working in different sectors. You can see the bottom, there are each regions. There are 4 vertical lines are mentioned, and it is clearly demarked at the bottom. The first one, the dark blue, shows the oil and gas sector. What is the salary? The people working in petrochemical, where the refineries, that is the second line. The next vertical line shows power plant. People working in the power sector, or the power plant, power related structures. And renewable energies, renewable structures. The people working in renewable energy sectors, what is the salary? You can see the salary part here. We can see that there is vast difference between region to region. The cost, the salary level is increasing or decreasing in some country, and the topmost is Australasia, where Australia, New Zealand, and nearby areas, where their salary level is high, and particularly the people working in oil and gas sector, the salary is very, very high. And slowly, it's meeting energy sector. There is renewable energy also just matching that one. And if you see compare the regional variation of this salary variation, if you compare Asia, so Asia, India comes under Asia, and if you see is almost equal. The people working in oil and sector, they're getting a higher salary, and slowly is going to meet the energy sectors. And if you see the average salary of the Asia, so 50,000, this annual salary is 50,000 USD. It converts today's conversion rate of 83 or 84 rupees per dollar. So the annual salary works out around 40 lakhs to 42 lakhs per annum. This is the average middle-level engineers that took the junior engineer and senior engineer and experience level and different sectors. Oil means that working in EPC, working in rig, working in offshore, all comprise the average rating. The 40 lakhs per annum is Indian salary, but same salary is almost, you can see here, North America and Middle East is 25% more, here 50% more, but this country is double. So Indian salary, the Asia salary is double, here 2 times. So this is variation due to the regional requirement, also the availability of skilled people here. Asia where more people are available, so skill is more, so demand is less or maybe equal or supply also equal. But there other countries, no, demand is more, supply is less. So that is the reason the cost variation, the salary variation in the different parts of the world. Here another interesting factor, and what are the women people working in oil and gas sector? How it is distributed. So this is the latest survey 2022. You can see they're comparing 2017 and 2020. They're comparing 2017 and 2020. That's the last 2-3 years back. And what are the improvement in the women employees in the energy sector? So if we come to the last column here, total, all common, no, the 22, but there is no big change from the women employees. From 2017 also same, 22% of the total people employed in energy sector. And now also 2020 also same 22% there is overall. But coming to the country, it varies from region to region. So Europe, there is a big change from the last 3 years, no, within 2017 and 2020. The women employees working in energy sector is a big jump. Thirty-three percent in Europe countries. And I think today, all the people working in energy sector, even in India, everyone is telling that D and I, diversity and inclusion. There's more awareness comes within our Indian energy sector. Now all the companies are now focusing or recruiting more women employees in their organization. There is a good scope. People who are engineers graduating in coming years, no, there is good scope for them to absorb by the energy sector. Because today there is a lagging, no, there is a long gap, big gap between other countries, and India is focusing more women employees in the energy sector, and that's going to happen. You can see change. So the next report, I'm sure, the next report of this one population, sure the ACL level, this is going to increase. You know, the government is taking steps. Even not only government, the corporate companies, each the PMC company or EPC companies or themselves, they're having the rules and regulations. They're recruiting the people of more women employees in their organization. It's going to improve. I'm sure it's going to improve, and there is a good opportunities for women employees, women engineers to enter into the energy sectors. Then another interesting factors, there's another survey. It shows what are the people, the age group in the old tradition, and you can see oil and gas industries, and also the comparing renewable energy. What are the average age? If you see the start from the top, the youngsters in oil and gas are very less entering into the oil and gas industry, and you can see the right hand side, 18 to 24 age group, the 10%. And again, the oil and gas industries, you can see the senior people were 29%, 35 to 44 years, 29%. Youngsters, again, 25 years to 34 years. Young engineers are 26%. But same thing, when come to the renewables, as per the recent record, the population is 41%. The people working in the sectors, there is good demand development. And more senior people, because the oil and gas is an old industry, and where more people started their career very late, and they are continuing in the oil and gas sector. And today there is a shift, we call energy transition. All of the companies who worked in oil and gas sector, they're moving towards renewable energy. So all the employees given an opportunity to upskill their knowledge, so they can train in different technologies. They can move from the traditional oil and gas experience design, they'll move to renewable. So companies are focusing on, so everyone, the new technical terms in terms of the energy sector is ET. Each company will take ET. What is ET? Energy transition. Everyone is focusing on energy transition job. Why they're doing energy transition? To reduce the carbon. That is the main aim. And technology also developing, so that the cost will come down, the power produced by the new technology, renewable energy. That's why more companies are moving towards renewable energy. And we can see the good opportunity for youngsters entering to the renewable energy. It's going to happen in coming days. And what really is happening in other regions, the development.
Excuse me, sir.
Yeah.
Excuse me, sir. So please, can we have a break for 5 minutes?
Sure, okay, good.
We'll ask everyone to join by 7:05 using the same link, sir.
Okay, good. Same link, okay.
Okay, sir. Thank you,
Thank
sir.
you.
So I
Thank you.
request everyone to join the same link by 7:05. Okay, there'll be a link, another link sent.
Okay. There is a big improvement in the this power sector. So in future, there is, you can see uptrend. So all the countries everywhere there is a jump in the power production through renewable energy. Similarly, the job opportunity also everywhere. India, you can get also United States, Europe, and China. And once we've seen what are the opportunities, so far we've seen what are the opportunities for us to get the uptrend. So there is, from this above things, we were able to observe there is a good opportunity for engineers to work in energy sector, and to get inside what are the technical skills required to get inside this field. The first one, there are two skills that is called technical skill and soft skill. Coming to the technical skill, the knowledge in basic engineering. Any skill or any knowledge, if required, you can see that any basic engineering is minimum required. It can be civil engineer, electrical engineer, or chemical engineer, instrumentation engineer. This basic skill is required. And with that, there are more scope for, we can say, the electrical engineers in the energy sector, because whatever we are producing the energy, each renewable time, that source to the final destination. You cannot use the entire electricity produced at a particular place. You have to transmit to other place. The power distribution, where you have to mean the new grid integration. So from offshore to onshore, from offshore the solar to other people, it should reach the people or it reach the industry. So there we're going to develop many power distribution system. There is a good number of electrical engineers where the grid integration is required, more people are required. Similarly, all discipline, not only electrical, with the major requirement, and all related engineering, civil, mechanical, instrumentation, all are required to increase that capacity. Not only the technical skill, I can say the basic engineering, you should have the soft skill. Other than the technical skill, you should be good in problem solving and good in project management. Then team player. All these projects are developed or managed not by individuals, not by individual discipline. So all discipline work together and produce the final output. So you should be a good team player when you enter the and good communication skill. So that is important. You will be interacting with the different vendors, different nationality of the people, different region. So good communication skills also required. Both technical and soft skills are very, very important if we enter into this field. Then what are the education pathways? If you can see, so once you have the engineering degree and we are entering the field, that is not sufficient. You have to enhance your knowledge with any certifications. So that is not possible now as the young engineers, you are graduates. So once you become the graduate engineers, once you enter to the any young engineer at the junior level, you have to upskill your knowledge with certifications if you are continue in the energy sector. There are many certification agencies. As you sit down in the right side, you can see the project management PMP. So the project managers are one of the key people driving the project. For you should get certification is available. There is PMP. Then certified cost professional, the CCP. People in construction management. So there should be get certification from the CCM, that is called certified. Some people interested in fabrication, so they should be certified by the welding inspector. There are many certification agencies are there, so you should get certified and you should upgrade your knowledge. It is just getting certificate also not enough. Then you have to continuously through workshops and seminars. Online courses also available, and you can update your knowledge in the industry. You have to go with the trend in the recent development. Okay, once we get the certifications, and this is one of the important that I can say, the softwares. What are the softwares used by the different people in the different sectors? So I listed on a few important softwares. To enter, if you get the job, people, the young engineers, you should familiar with any one of the softwares applicable to your domain, your discipline. The first two are the mainly for civil and structural engineers. All the industries, energy industries, that are using this software. StatPro is the one of the important analysis and design software used by the civil and structural engineers. And SAX is the another software used for offshore structural engineers. So you should know at least one software, at least good familiar with this. Then getting opportunity job in the energy sectors is very easy. Software listed only CSR2 is pipe stress analysis, and PVLite for vessels are the software used with the mechanical engineering terms called as piping engineer. Engineers will use the analysis software called CSR. The PVLite is the exchanges, equipments, mechanical equipments design that will be used mechanical engineer. Then another software called ETAP is when used by electrical engineers for working in the industries, the energy industries. The Dialux is another software using in the Luminex, the power calculations. Other than this, we're using the smart plant instrumentation. The instrumentation engineers are using the smart plant instrumentation. Then another material engineers are using a smart plant material and pipe net. Then another chemical engineers. Generally, these last two are used by chemical engineers. They're called as process engineers or safety engineers. Pipe net and Aspen. These are the key important softwares used in the industry. And if your engineers are familiar with any one of them, this software, you will have the added advantage to enter into the energy sectors. So the people, there is another set of softwares available other than this. These are the one the analysis and design software. Another set of softwares available in the markets are for drawing preparation, the 2D model, 2D drawing and 3D modeling. So those are called AutoCAD is the basic tool to develop the drawing. Then microstation, another software to make the 2D drawings. Nowadays, the drawings not prepared in 2D, they're preparing 3D model. The entire structure of the entire plant will be modeled in 3D. Then drawing will be extracted from the 3D model. So those are the software called Tekla is mainly used for steel structures. Then E3D and S3D are the another specialized software. You can model entire plant using the software. That software will come full-scale virtual model. So that model will be used to avoid the interface between the different discipline. So those are the softwares mainly used by the designers. So the people come out from the mainly from the diploma holders. They're called as the designers. They'll be using those tools: AutoCAD, Tekla, E3D, and S3D. Mainly the engineers using this listed software. So if you are familiar with this software, it will be a good chance for you to enter into the energy industries. Then coming to the what are the different roles and the specialization. As you told earlier, is any engineer, civil, mechanical, electrical, they're working in energy sector, it's called energy engineers. Then there is another potential for energy analysis also. They can analyze the different power distribution, consumption, etc. Another comes project manager. There are also important people in any project. There will be project manager who control the entire project. Then there is good opportunity for people to research and development. Nowadays, the need is new field. The renewable energy field is new field. We need more innovatives and technology people. So if you are interested in innovations and you want to do R&D, there are many companies that are having the energy sectors that are having the research and development team, R&D. So if you are passionate in innovation and developing the new, you can attach to this department. Then regularly the government, the people doing the policy and regulations will develop the government. These are different roles in the energy sectors. Then what are the companies in energy sector? You can say generally the energy sector, the projects are managed into 2-3 categories. These new terms for you people just want to touch those topics. But EPC, I already discussed. EPC means the energy projects is executed in terms of term called EPC, engineering, procurement, and construction. So the client, the owner will identify the suitable contractor or EPC company. You will give the entire job to the particular company. They will do the engineering, they will do the procurement activity, they will do the construction. So there is a lump sum is given to the third party or the contractors. You will do the project, execute the project for the client. So those kind of projects are called EPC project. Then another called EPCM is another form of awarding the project to the contractors, engineering, procurement, construction management. So the construction will be managed by the owner. So you will identify the contractor to identify the construction activity, but EPCM, his role is the engineering and procurement and construction management. You're managing the constructions. Then PMC, another important role for this energy sector is the PMC. They're calling project management consultants. So some companies are involved in PMC. They'll be working for the owners. So owner will give the full certification for this PMC people to manage the other EPC or other EPC people. So the PMC is the main role. They will support the owners or the client, and they will ensure that the defined qualities, defined standards are followed. So they will be closely working with the owners. There are 3 different types of project executions are nowadays using all the energy sectors. So these all 3 are interconnected. So the EPC means engineering. So starting up the project, the engineering and do the engineering, and they will link with the procurement. They will get the equipment order, and once the procurement is over, then construction started. During the construction, there is a good relation between procurement and construction team. And during the construction and at the end of the construction, there will be good relationship between engineering and construction. They have to supervise, they have to resolve any queries at the site. So these all 3 are interconnected. EPC means engineering, procurement, construction are interconnected. So each team, we need the people to execute the job. That will set up people experienced in the detail engineering. Some set of people that are very good in procurement. Some people are good on construction. So all 3 are mixed. we can say the total project cost, no, we get the cost wise, engineering cost will be around 10%, so 8 to 10% of the entire project. And the procurement till around 40%, the total cost of any project. Then construction another 30 to 40%. So engineering is starting with the engineering and coordination with the procurement. They would procure all the materials, and we can see construction will execute the project. So we can see the next slide, the little detailed workflow of this EPC. You can understand your role. As an engineer, you enter into the organization. What is your role? So many of the engineers, you don't know. Once you join the EPC company or the energy sector, what is my role? There is one of the big questions among the young engineers. This slide will give some quick update. What is really happening in EPC company? So once the client or owner want to put the project, new project, he will award the project to the suitable consultant. It may be EPC or EPCM or PMC, but to execute the project, he will go to the EPC company. So you want to engineering, procurement, and construction to be managed by another third-party consultant or a consultancy company. So once the client decided he want to put new projects, then he will give the LOA, this letter of award. Once the letter of award is given to the company who is going to do the EPC, the start of the project is start with KOM, they call as kickoff meeting. They will involve the client also in the kickoff meeting. They will review all of the design parameters, all the input, what are the legal requirement, what are the statutory requirement. They will review entire project. They will have a dedicated meeting, whether they will get all the inputs, but all the schedule is very clearly understood by everyone. They will do the kickoff meeting with the client and they will sort it down. They will put the minutes. That is the starting of the EPC project. Client started awarding the job, and the team members in the EPC company, they will have the meeting with the client. So once that is done, kickoff meeting started, the project engineering phase started. So engineering phase started is nothing but in the E, where all the engineers are involved in executing the project. We have to do the detailed engineering when the project is awarded. So this is, I already told, this is teamwork. It's not one department is going to execute the project or do the design. So this team of engineers in the project are sitting together and they're going to develop the project. So it starts with always process. Process is the first team who define the process flow of the particular project, and they will define what are the equipments required, and what are the operating conditions, the fluid flow or whatever may be. They will define the entire thing. This is the first input is released from the process engineer. The process engineer, nothing but chemical engineers. The chemical engineers are called as process engineers in EPC company. Once the process engineers define the workflow, the process, and equipment, and operating condition, temperature, that data, the PNID and PFD, process flow diagrams, that goes to mechanical department, where mechanical engineers will do the equipment design. And they will call for suitable vendor, supplier. They want to do the mechanical equipment. They will go for the outside supplier or vendor to meet the process requirement. Generally, all the EPC company, the mechanical departments have the 3 subdivisions. They're having one department is called static. They will deal with the equipments in static mode. Then rotary, machinery, then packaged equipments. The 3 subdivisions under mechanical department. Any engineers entering to the EPC, they will be assigned to any one of the departments, static department, or rotary, or package equipment. Then comes here the civil engineers. What is the role of civil engineers in EPC? They have to design the foundations for the equipments, any process equipment or oil and gas or energy sector. There are big equipment, number of equipments. For that civil engineer, they have to design the foundation. So again, design the foundation, you have to go through the soil investigation report. You have to choose the right foundation, whether it's cellar foundation or pile foundation. You will be do the design of the entire structures inside the plant. So steel structure means how to design the steel structures. Civil engineer should take care of the environmental load, call as wind load, seismic load, and also different codes. If you're going to construct the plant in India, you have to do the Indian code. You are going to construct the plant in other part of the world, Europe, you have to use European code, or Russia, you have to use Russian code, China, Chinese code. You have to be familiar with the country code and you have to do the design. And you have to fulfill the other discipline input. So the civil engineer closely worked with mechanical department, also with electrical instrumentation. There will be some equipment design, some routing, cable routing will be separated by structure. So the civil engineer role is closely coordinated with all disciplines. Then another important any field is piping engineers. So piping engineers is nothing but mechanical graduates that are assigned to the piping department. So the piping department, once the process department finalizes the equipment, the piping department will do the GADs, general arrangement drawing, the plot plan. There is the basic input for civil. All other discipline will follow the piping discipline layout and piping GAD to do the pipe routing. Any plant, the fluid should move from one place to other place. That is through pipeline. So the piping discipline will closely work with process department. They have to design the pipeline. They have to maintain the temperature. They have to maintain the pressure. They have to take care of the corrosion resistance of the material. So the piping is one of the important piping engineers are important in the any EPC project. Again, the piping engineer, like mechanical engineer, there are 3 to 4 subdivisions. Piping engineer comprises of layout engineers, a set of engineers, then pipe stress engineers, piping material engineers, then CAD team. I already told the entire thing will be designed to be modeled in 3-dimensional. So there's CAD team also attached to the piping. Then comes here electrical engineers. The main role of electrical engineers in any plant in the EPC project is they have to find the power distribution, power system. They have to integrate all the power system inside the plant. And they have to ensure that as per the process safety, based on the hazardous area classification, you have to protect the cables and the instruments and the equipments. So they will closely working with instrumentation department, also the civil department where they will do the input. Then instrumentation department is another department where the flow measurement, by instrumentation department again closely work with process department, where the flow measurement, the temperature to be maintained, automation we have to do. All these flows, everything will be taken care by the instrumentation department. They will closely work with the process and the electrical department. So once all these engineers are worked together and produce the drawings or document, mainly they will probably call the MTO. Before that, this team will be supported by the cost control engineers. So these are engineering department. Another other division is cost control. These cost control engineers will measure the throughout the project, within the budget, whether the project goes within control. There is a set of engineers working for cost control department. Another set of engineers working for planning department. They will do the progress schedule as per the client, what is going, progress is as per the schedule. They will monitor the progress of the project. They are called planning engineers. Then HSC. HSC again comes with QHSC, quality, health, safety, and environment. This separate division, they will emphasize safety in the or design and construction activity. So all these people, once they completed the design, it will go to the MTO. MTO is nothing but material takeoff. What are the equipments required? What are the construction materials required to complete the project? They will, each discipline will give the output that is called MTO, or sometimes called as bill of material. So once that is MTO is prepared, then it goes to the procurement department. Procurement department, I already told this entire engineering is only 10%, and mainly procurement department, the major cost goes to the procurement handled by procurement department. So procurement department get the MTO material. He will identify the source of the material from the outside market based on the engineering recommendation from the each discipline. They will find the right vendor, right supplier, and they will order the material, order the equipment required for that particular plant. So once the material is ordered, that will reach to the site. Then construction will start. So all these three phases, it is controlled by the project manager. This is another team who are running, supervising entire activity, both engineering, procurement, and construction. This is managed by the project manager. The project managers in the sector EPC company is called as PMT, project management team. They have set of engineers. They will ensure that the interface between all the interdisciplines are going well. They are closely interaction with the client requirement. They will attend the meeting with the client. Any changes are incorporate. This is the project manager role. Project manager ensure that the project is going on schedule or within the budget, and also completion on time. So the project team, separate team is working on the project manager, team of engineers you assigned to the project manager team. So this comprises the whole EPC of the any project, any energy sector project. Where it is followed in oil and gas sector, it is followed in refinery team or new energy, anything, no, any new projects. So this is the setup. So as you all joined any one role, so you will be in the part of engineering phase. You will be assigned to the procurement department based on your knowledge, skill, and interest, and you will be assigned to the PMT team. So the engineer role in the team is the different engineering phase and the procurement phase. Sometimes some people will be interested in construction, so they will be assigned to the site. They will be managing the construction activity. So you can see the EPCs, is engineering phase we've seen with the help of different team members. And then procurement team is P, that are controlling the entire procurement activity of the plant. And the construction team is managing the entire construction. So this is, picture gives the overall what's happening in the EPC company and what is the role of engineers. Then next, once we know what's what, very important things in the professional organization is networking is very, very important for career growth. If you want to enter, starting with your entering to the field, that is networking is very, very important. Once you are joined, you are producing, you are part of the team, again, good networking is very, very important in the sector. And my suggestion is, when as you are in the student, you should be at least member of any one of the professional organizations. There are many organizations with respect to each discipline. For civil engineer, there are called as Institution of Engineers India. They are having all the membership of civil engineers, mechanical, electrical instrumentation. All engineers can become the member of the Institution of Engineers. You should be a member of any one of the organization in your student. Also, you can have student membership. Once you become the graduate, then you can become associate membership and fellowship. There are good roles and responsibilities there in each organization, each professional organization. Each one should be at least in any one of the organization when you are attending the interview. For civil engineers, there is Indian Concrete Institute. These are other professional bodies there. In electrical engineers, you can become IEEE, IEEE membership. Mechanical engineers, there are many organizations. One the important is ASME. For instrumentation engineers, is ISA. There are many organizations that are working towards they're developing. Once you have joined the membership, they will be conducting the seminars, webinars, meeting, networking. There you can meet the professional people in the workshops and seminars. You can have a chance to go through what is happening in the industry, what is the latest development. It is a good chance for you to get more knowledge about what's happening in the field. So the networking is very, very important, and at least you should be in any one of the professional organization. Then another thing important is you should have the good internship at the
Excuse me, sir. Please, excuse me, sir.
Yeah.
Sir, please can we continue after 5 minutes, sir?
Yeah, okay. No issues, yeah.
Okay. I request everyone to join the link by 7:40. We'll be sending the link.
Okay.
Please join us, sir. Thank you, sir.
Thank you. Yeah, good. Yeah, we'll start.
Yes, sir.
Hello.
Sir, we can start.
Okay, good. Yeah, nice. Okay, we'll continue. We'll close quickly. Few more slides only. Yeah. Coming to the next one, how to get inside the field. Start with internship and entry level positions. So the main advice is look for internship at entry level position, mainly in the energy companies. The people, students in final semester or something now want to enter, they should have good internship in the energy related companies. Also, they can join any research institution where the government organization are also there. Those are working in the energy sector. If you get internship, that is good advantage for them. Another advice is you have to prepare your resume and cover letter to highlight your relevant skills and experience. So once you are done with your graduation, you are going for interview, you should prepare the resume should be in the highlighting all your skills you acquired in the internship. Another important point where the students are lagging is prepare for the interviews. They should know about the companies before attending the interview. Many times I'm interviewing the students when asking about the company details. Many of them don't know about the company. So at least they should do some kind of research work. They should prepare for the interview and understand what is the specific role they're applying for and what is the company doing in this industry. So if they go with some kind of preparation and know some kind of homework, we call as homework, then there are more chances for you to get inside the company. And another part, just quickly about my company. Our company is Technip Energy. I'm working Technip Energy. This is one of the leading engineering technology company for the energy transition. We are working in, we started oil and gas, refinery, petrochemical, and moving towards the energy transition project. And we are around 65 years old company. Head office at Paris. And total employees around 16,000 people working in 34 countries. Coming to the next slide. So our vision is accelerating the energy transition for a better tomorrow. So moving towards energy transition project. And this is geographical location of our companies with different places. These are the main operating centers placed at Rome, Paris, London, Houston, India, head office Mumbai. Also, we're having office at Abu Dhabi and Kuala. These are the main engineering operating centers. And there are 111 nationalities. And for information, we are taking the women employees 50% on every graduate intake. So that is our company policy. We are encouraging diversity, and most of the people who are taking 50% intake. And just quick about our companies, we are mainly doing consulting. We are doing EPC projects and also PMC project, and mainly modularization. We are doing mega project in Russia and other part of the world where the modularization of civil structures is utilized, and we are doing technology upscale. On the right side, you can see our markets. We are involved in all the new trending markets, natural gas, mainly LNG, hydrogen, downstreams, and we are entering the new field called carbon capture and utilization, where the carbon can be captured at the source. These are the different areas we are working in today's. And a little more on detail where we are working this LNG. We are mainly working in the LNG plant, both onshore and offshore. So Technip is one of the company. The first floating LNG is designed by Technip for the client shell. First floating offshore structures, that is called FLNG. And we are working on carbon-free energies, mainly green energy, green hydrogen, then floating offshore wind. The right side, you can sustainable chemistry. We are working on biofuels and circular economy and decarbonization. We are low carbons, we can say energy efficient blue hydrogen and carbon capture, utilization and storage. These are the main our portfolios or business lines. We are working on that. And this slides gives the Okay, what are the major owners who's running the oil and gas projects, and they're the energy sector clients in the global world level, and all the companies who was working in this traditional energy, now they're moving towards renewable energy. So everyone, all the big companies, these are the world level companies, they are recruiting engineers during the entry level, also during the lateral entry. So all these companies are working in the owners of the oil companies, and they are moving towards energy transition. We come to the India, these are the we can call it the public sector companies where the mainly working in oil and gas. Now they are also moving towards wherever possible energy transition projects. I mean, Indian Oil, ONGC, Bharat. And also the private operators in India, private owners, the Reliance, Sky and Petro. Reliance, they're moving mainly towards renewable energy, hydrogen fuel, like that, low carbon energy. Everyone knows looking for moving towards renewable energy and coming away from this oil and gas industries. So this another pictures gives overall what are the companies involved in energy sector. These are the top companies in the world. We can say around 15 companies are listed. More than 10 companies are our office in India. The listed companies, they are looking for engineers. The GT, also the lateral entry. So these companies having the office in India, made in South India, Chennai, we're having the most of the companies are having the branches in Chennai, and every year they're recruiting the people. So people looking for a job, they should aim for some company and prepare for them and equip themselves to enter the union of the company. These are the outline of the EPC companies working towards the energy sectors. So with this, I'm concluding my today's presentation and come to the last slide. So you people can contact me related to your any doubts or anything related to energy sectors or your job opportunities. You can meet me at any time. Connect me through LinkedIn. This is my LinkedIn ID. And concluding my today's presentation, and thank you for your attention. In conclusion, I encourage you all to capitalize this energy sector's exciting opportunity. Thank you. We'll go for any question answer session if anyone. Yeah. So you have any questions? Then someone can.
Sir,
Yeah.
sir, do you feel anything is lagging in this energy sector that we can work on?
Can you please repeat? I could not get you.
Sir, do you feel anything is lagging in this energy sector so young engineers can work on that problem, or like what is the issues or something we want to work on?
Yeah, we are having the internship facilities, the people can enter into the field, and there are guidelines. There are our companies having the internship facilities where 2 to 3 months people can work on this internship. We are
Okay, sir.
going on every year. We are recruiting in the internship. Interns can join and they can get knowledge during the period. And if they are performing well, we are recruiting these people also through internship mode, where you will get exposure to this energy transition from our company side. Then there are many institutes also outside that are doing some kind of assistance, no, those who are involved, the want to enter into the energy field. There are other institutions that are giving some trainings. And government sector also, they're encouraging people to enter into the renewable energy. There are many organization, government organization, they're allowing internship. You can check with them.
Okay, sir. Thank you.
Okay, good. You people can connect me through LinkedIn if you have any specific doubts, any clarification. I will try to connect you through LinkedIn. Yeah,
Sir,
yeah.
what challenges should new graduate expect when entering the energy sector?
Challenges. So the young engineers, the challenges is they should, as I told, they should come with any one of the softwares and what are the technologies going on. They should do some homework. And once they join, no, there is some people joining as young engineers. There are all the companies that are having the training program, graduate engineers training program, where they will train you in this. Some companies having 3 months, some companies having 6 months, or our company, Technip, we are having a 1 year training period. So there we will train you, we will tune you to what is required to work in this project. So as entry level, there is no big challenge, but you should good in analytical, as you told, problem solving person, and you good in any one of the softwares, and we will train you. We are having the detailed training program, and once joined, they will be comes working under the mentor, and they will guide you and train you. So you can manage the challenges in the sense you have to get the update your knowledge. We can say you have to current trend, you have to get your knowledge, then work on that. That's one of the big things we have to do in terms of when entering to the energy sectors.
Thank you, sir. Sir, I would like to ask you a question, sir.
Yeah.
Is there any opportunities for non-mechanical students or non-civil students in the energy sector, sir?
Non-mechanical, energy sectors, we're having another department called document management department, where they're not technical people. We are recruiting the other than non-technical people. There is big department. Once the design and documents produced by engineers, so they have to manage the entire documentation part. There is a separate department called document management team. So where we are recruiting people in terms of people with BCom, BSc, or BSc Computer Science, those non-technical people, we are recruiting people. There's a separate department is there. They have to manage the documents to send to the client, the distribution to the different department. They have discuss with the vendors or supplier. So there is avenue, and there is a separate team working on that. Other than that, we are having some IT team where the people with experience in computer science or MCA or those field, no, we are doing software development for in-house. There are also some other non-technical people also join. The document management team is another team department where the non-technical people can work in the energy sector. Yeah.
Thank you so much, sir.
Thank you. Okay, if no more questions, we'll conclude. Okay.
Sir, we are in the end of the session.
Okay.
We had an eye-opening session about the energy sector. Sir, thank you so much for being there for us today.
Okay, good. And also, I take this opportunity wishing you a sustainable, a successful career and a bright future. Take care.
Thank you all the participants for joining us today. We hope you found this session both informative and inspiring. On behalf of gSARC and GCT Talks, we extend our heartfelt gratitude to Mr. Asaithambi K S, sir, for taking the time to share his knowledge with us. Please make sure to follow us on Instagram, YouTube, and LinkedIn channels to stay updated with our upcoming events. The link have been shared in the chat for your reference. Thank you, sir.
Thank you. Yeah, good. Take care.
Excuse me, sir. Excuse me, sir.
Yeah, can you hear me?
Yes, sir. Sorry for the inconvenience
Yeah,
due to
yeah.
time restrictions.
Yeah, it looks like that is happening all the meetings or this one only. Or regular you're happening like that. Is it usual practice?
So for the past, so no, sir,
Yeah.
due to some inconvenience, this is happening for the past few meetings, sir.
Oh, okay, okay. Yeah, you find
We're really
alternate
sorry
way.
from our side, sir.
Yeah, no issues.
Yes,
You
sir,
try
sir.
to find alternate way how to overcome this issue. We
Yes, sir.
find out. Otherwise, no people attending this workshop or let's say webinar from holidays. No, if they break, no, they also lose interest. So you should make some
Yes, sir.
alternate arrangement to overcome this issue.
Sure,
Otherwise,
sir.
okay, yeah, no issues.
Yes,
Okay, good. Take care.
how much, sir?
Yeah. Thank you. I'll close now. Yeah.